is 7.1, linear and nonlinear systems of equations. So our goals, we're going to use a method of substitution to solve systems of linear equations in two variables, and use method of substitution to solve systems of nonlinear equations in two variables. So linear and nonlinear equations. So we're going to study 4 ways to solve systems of equations in this chapter, beginning with the method of substitution. So we're going to use linear or nonlinear, two variables. We're going to use the graphing method, elimination, and Gaussian elimination. For method of substitution, we're going to solve one of the equations for one variable in terms of the other. We're going to substitute the expression found in step 1 into the other equation to obtain an equation in one variable, solve the equation obtained in step 2, then back substitute the value found in step 3 into the expression obtained in step 1 to find the value of the other variable. And then we're going to check the solution satisfies each of the original equations. So first, let's go to checking solutions. We want to determine whether the ordered pair is a solution of the system. So we have 2x plus y equals 5, and then we have 3x minus 2y equals 4. And we want to check this ordered pair 2, 1. So in order to do that, we need to plug it in into both equations and see if it's true. So we plug in 2 for x and 1 for y. So 2 times 2 plus 1, does that equal 5? So 2 times 2 is 4 plus 1, that is definitely 5. Then we check in the other equation, 3 times 2 minus 2 times 1, does that equal 4? So that's 6 minus 2, and then we find that 4 does equal 4. So therefore, this ordered pair is a solution of the system. Now let's solve a system of equations by substitution. So substitution means we're going to replace something for something else. So what we want to do is we want to first isolate one of the variables. So let's work with these equations. Let's go ahead and isolate. We can isolate y here. So we're going to do that by subtracting x, right? So my first equation is x plus y equals 4, and then I'll subtract x. So I have y equals 4 minus x. So what I'm going to do with this y equals 4 minus x is I'm going to substitute into this second equation here. So x minus 4 minus x equals 2, and then we'll solve. So one thing to check is as you're doing this, you should have the same variable or one type of variable once you plug it in, since we're only working with two variables. So we should have x's only so we can solve for it. First, let's distribute the negative. X minus 4, and negative times negative is a positive x, equals 2. So that equals 2x minus 4 equals 2. And we add 4. We get 2x equals 6. Divide by 2. So x equals 3. Then, now that we know that x is 3, we can plug it in into one of our original equations to find what the y value is. So let's go ahead and plug it into the first equation. Either one works. So x is 3 plus y equals 4. Subtract 3. We find that y equals 1. So the solution to this system is 3, 1. Now what we can do is we can always check to see that it's true. So just like we did in the previous example, you take the solution, the ordered pair, and plug it into both equations to make sure that it is true. So again, this is your x and this is your y. So plug it into equation 1. We have 3 plus 1 equals 4. We want to see if that's true, and so yes, 4 equals 4, so it works in equation 1. Let's check in equation 2. So we have 3 minus 1, does that equal 2? 3 minus 1 is, in fact, 2. So we checked and we verified. So try example 2 here. Solve the system of equations by substitution. So pause the video and try it out. So when you solve this equation, you find that the ordered pair is 3, 3.